Out here, I'll just talk you through it. We have got a graph here with log base 10 of p on my y-axis and t on my x-axis. We can see it's a straight line. We're told the gradient of the straight line is 1 over 200, and we're told that the y-intercept of the line is 5. So, straight line starting with y equals mx plus c, but my y-axis is log base 10 of p. My gradient is 1 over 200, my x-axis is t, and my y-intercept is 5. So this is the equation of this line. We're told that this line is modelling this equation p equals ab to the power t, and part b asks us to work out the value of a and b. So I want to take this equation and write it in this form. So I want to remove the logarithm. The way I'm going to remove that logarithm is I'm going to do 10 to the power on both sides, because then the 10 to the power of the log base 10 will cancel out and just leave me with the p. On the right hand side, we've got 10 to the power of 1 over 200t plus 5. It's important to note that all of this will be in the power. But we can split this up with index laws, because if the powers are being added, I know the bases are being multiplied. So, p is 10 to the power of 1 over 200t multiplied by 10 to the power 5. Now, the 10 to the power 1 over 200, if I put that in my calculator, I get 1.02. And all of that is to the power t. The 10 to the power 5, put that in my calculator, or just common sense, we get 100,000. And then I've just swapped these over to write it in its usual form, so it looks like this. So p equals ab to the power t, where a is 100,000 and the b is 1.012. Part C says, with reference to the model, interpret the value of the constant a and the constant b. Well, this a, the 100,000, that's the value of the population. So that's going to be what p is if the t was 0. Let me just repeat that. If the t was 0 here, so if after 0 years, we're going to have 100,000 times 1, which is 100,000. So that a represents the initial population, or the population when t is 0. The b? Well, the b is what we're multiplying by every year. We're multiplying by 1.012 each year. And multiplying by 1.012, that's a 1.2% increase every year. So b represents a 1.2% growth in the population each year. Part D says to find the population predicted by the model when t is 100. So I've just taken my equation from here and I've substituted 100 in instead of the t. And that gave me 329,648.6. And we were told to give our population to the nearest 100,000. So I've said it's 300,000. Then we're told to find the number of years it takes to reach 200,000. So again, I've taken my equation for the model and I've made the population 200,000. Then, solving this equation, I've divided both sides by 100,000. So 200,000 divided by 100,000 is 2. I've then taken logs of both sides. So log of 2 and log of the 1.012 to the power t. I can then take this t and bring it down here using the laws of logarithms, which then allows me to divide both sides by the log 1.012, which gives t as 58.1 years. And then part E, I've not written this down because there's not one specific answer for this. There's a few different answers you can give. We need to state 2 reasons why this might not be a realistic population model. So 2 reasons. The first reason I'm going to give is, according to this equation, the bigger t gets, the bigger the population gets. And it's going to keep on getting bigger and bigger and bigger and bigger. There isn't an upper limit for what the population could be, which is a bit unrealistic, because at some point this population is going to run out of food or run out of space, or there's going to be some reason for an upper limit to the population. It can't just keep on going forever. So that's one reason why it's not a realistic population model, because there's not an upper limit. The second reason why this might not be realistic is 100 years is a really long time. So to expect the population to continue growing in the same pattern over 100 years is a bit unrealistic. In that time, there could be droughts, there could be food shortages, there could be illnesses, there could be disease, there could be an outbreak of war, who knows. A whole host of reasons why the population is not going to continue growing according to the same model over such a long period of time. So the sentence I'd write for that is, 100 years is a long period of time, and it is unlikely that the population will continue growing according to the same equation over such a long period of time.